A sequence is an ordered set of numbers called terms. Let's have a look at a few examples. In this first example, we have 4 terms. My first term is 1. My third term is 7. And then we have our second and our fourth term, which is 4 and 10. In my second example, I have a total of 6 terms. My fourth term is 63. And in my last example, I have a total of 5 terms, where my fifth term is 16. This should give you a better idea of how to use the word term. There are 3 different sequences that you need to be able to identify: a linear sequence, a quadratic sequence, and a geometric sequence. A sequence is linear if it increases or decreases in equal steps. This first sequence is linear because it decreases by 9 each time. The second sequence is linear because it increases by 3 each time. Every linear sequence has a position to term rule, and this rule tells us how to work out any term in the sequence. For this first sequence, the position to term rule is 99 minus 9n. So if I wanted to work out the fourth term, which I know is 63, I would do 99 minus 9 times 4. So I would replace the n with 4 because I'm looking for my fourth term. So I'll have 99 minus 36, because 9 times 4 is 36, which will give me 63, which I know is my answer. It is important to note that the n represents the position of the term in the sequence, so we call this general rule the nth term. But why is this useful? Well, if I wanted to work out the 7th term, I could just subtract 9 from 45, and I'll get 36, which is really easy. But what if I wanted to work out the 100th term? Well, instead I can use my formula. I can replace my n with 100. So I will have 99 minus 9 times 100. I know 9 times 100 is 900, so I've got 99 minus 900. Now be careful, because this does give us a negative answer, and 99 minus 900 gives us minus 801, which seems right because if we're decreasing by 9 each time, and we do this 100 times, we expect our answer to be negative. And this is a lot easier than writing out our entire sequence. Let's have a look at this for our second example. Well, our position to term rule, or our nth term, is going to be 3n minus 2. Now we're not going to look at how to work out the nth term just yet. Let's check if this works. Let's try it for our third term. Well, if I replace n with 3, I'll end up with 3 times 3 minus 2. 3 times 3 is 9, minus 2 gives us 7, and our third term is 7. So we know this is correct. So what would we get for our 100th term? Well, let's replace n with 100. So for term 100, I will get 3 times 100 minus 2. 3 times 100 is 300, and minus 2 is 298. So my 100th term is 298. What about a geometric sequence? A geometric sequence is one that increases or decreases by a common ratio. So for example, in the sequence 1, 2, 4, 8, 16, our common ratio is 2, because each term is being multiplied by 2 to get the next term. So the difference between a linear sequence and a geometric sequence is a linear sequence focuses on adding and subtracting, whereas a geometric sequence focuses on multiplying or dividing. What about a quadratic sequence? Well, let's have a look at the quadratic sequence 2, 9, 18, 29, and 42. If we look at our first difference, between 2 and 9, we have plus 7. Then between 9 and 18, we add 9. Between 18 and 29, we add 11. And between 29 and 42, we add 13. It is the second difference in a quadratic sequence that is the same. So if we look between the 7 and the 9, we're adding 2. And then we're still adding 2 between the 9 and the 11. And then from 11 to 13, we are also adding 2. So to find if a sequence is quadratic, you have to look at its second difference. This will be explained in more detail in a different video. So a few key points to remember and things to look out for. When we are using the phrase Tn, this means the nth term. So T5 will mean the 5th term, and so on. When we're looking for geometric sequences, we're looking at our common ratio. So what can we times to get to the next term? When we're looking for linear sequences, we're looking for an increase or a decrease, and it has to be in equal steps. If it's not in equal steps, it's most likely a quadratic sequence. And for a quadratic sequence, we have to check our second difference. A quick note on geometric sequences. If we had 50, then 10, and then 2 as the first 3 terms of our sequence, although we are dividing by 5 each time, instead we would say that we are multiplying by 1/5, because we always look at the multiplying aspect. So instead of writing divide by 5, we will use the reciprocal of 5, which is just 1/5, and we will say we're multiplying by 1/5, because this means the same thing.